Morning students, in this class I will be doing class 9 CBSE syllabus 10th chapter circles. This is a new chapter. In my previous video I have completed surface area and volume. Now I am going to start new chapter circles. So some basic concepts of circles and theorems involved in this chapter. To do the sums that I will explain first, then we will go to the exercise sums. So first one is circle. The basic things we know about the circles are, this is the center point of the circle. From this center point only we can able to draw the circle. Okay, then the line segment that connects the center point and any part on the circle is called the radius of the circle. And if the line segment that connects any two points on the circumference of the circle through the center point is called diameter. Through the center point is called the diameter. And this line is called the circumference of the circle. This line is called the circumference of the circle. And then sector and segment. Segment means when then other than this a circumference, after this chord, any two, a line segment that connects any 2 points on the circle, that is called chord. Okay, so these are the basic parts of the circle that we have learnt already in our previous classes. Then other than this, major segment and minor segment we will see. The region between the chord and the arc, that is called the, if it occupies the smaller space, that is called minor segment we will say. The region between the chord and the arc, and the smaller part of the arc is called the minor segment, and the remaining area minor segment, and the remaining area is called the major segment. So this part is called the major segment. This part is called the major segment. Major segment. Then comes sector. If we take a circle, the space between the two radius, and the arc, that is called the sector. So this is called the minor sector. This is called the minor sector, and this one is called the major sector. Major sector. Okay, so this is the center, radius, diameter, chord, circumference of the circle, minor segment, chord and the arc, that is called the minor segment, and the remaining area is called the major segment. And then sector is the region between the radius, two radius and the arc is called the minor sector, and the remaining area is called the major sector. So these are the few important things that we have learnt already in our lower classes. We will see few theorems. Okay, these theorems are very important. Okay. So first theorem is equal chords of a circle subtend equal angles at the center. So when we take a circle, equal chords of a circle. So if we take any two chords of equal length, the length of the chord should be equal. Okay. So if equal chords of a circle subtend equal angles at the center. So if the chords length are equal, they will subtend equal angles at the center. At the center, the angles that is subtended will be equal. This angle will be equal. That is the first theorem. Equal chords subtend equal angles at the center. Then second theorem is converse of that. If the angles subtended by the chord of a circle at the center are equal, if this angle is equal, then the chords are equal. Then the length of the chords are equal. That is the second theorem. Then third one is the perpendicular from the center of a circle to the chord bisects the chord. So if we take a circle, if we take a circle, the perpendicular from the center of a circle, perpendicular from the center of a circle to a chord, from the center of a circle to a chord bisects the chord, to a chord bisects the chord. That is, this length and this length of the chord will be equal. The perpendicular from the center of a circle, perpendicular is that straight line, from the center of a circle to a chord bisects the chord. Okay, so the length of the chord that will be equal when that is the bisection. It is bisected. The perpendicular from the center of a circle to a chord bisects the chord. Okay, then next theorem is the line drawn through the center of a circle to bisect a chord is perpendicular to the chord, converse of that. If these two, the chord, that is the line drawn through the center of a circle to bisect the chord, line drawn through the center of a circle to bisect the chord is perpendicular to the chord. This will be perpendicular. The previous theorem is, if the perpendicular is drawn to the chord, it will be equal. That is, the chord is bisected. Now, the converse of that is, the line drawn through the center of a circle to bisect the chord will be perpendicular. Okay. Then next one is, there is one and only one circle passing through three given non-collinear points. Okay. There is one and only one circle passing through three non-collinear points. Only one circle can be passed. One circle passing through three given non-collinear points. Collinear points means points on the same line. If we connect that points, if they are in the same line, same straight line, we will say that as collinear. Here we are taking non-collinear points. There is one and only one circle passing through three non-collinear points. Okay. Then next theorem is, equal chords of a circle are equidistant from the center. Equal chords of a circle. So if we take a circle, equal chords. So if the length of the chords are equal, of a circle are equidistant from the center. From the center, the distance will be equal. From the center, the distance will be equal. That is, this distance. This distance and this distance will be equal when the length of the chords are equal. That is one theorem. Then next one is, chords equidistant from the center of a circle. So this is the chord. Chords equidistant from the center of a circle are equal in length. This is the converse of the previous theorem. So few more theorems are there, that also we will see. Then theorem 8. The angle subtended by an arc at the center, the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Suppose this angle is x, then the angle subtended at the center will be 2x. If we are getting 30 degree here, this angle will be 60 degree. The angle subtended by an arc at the center is double. At the center is double the angle subtended by it at any point on the remaining part of the circle. This is theorem 8. Then theorem 9 is, angles in the same segment of a circle are equal. So this one is called the major segment. Okay. So this part is called the major segment. Okay. So angles in the same segment of a circle are equal. So if angles are formed here, the measure of that angles will be equal. Any angle that is formed. Any angle that is formed will be equal in measure. Any angle that is formed is equal in measure. Whatever angles are formed here, that measurement of that angles will be equal. Angles in the same segment of a circle are equal. Not necessary to be here alone. If the angles for this, if it is 30 degree, all will be 30 degree. In the minor segment, if angles are, if we are getting angles, those two angles will be off. If it is 20 degree here, the other one will be 20 degree. These two won't be equal, but angles in the same segment will be equal. Here also it will be equal, and here also it will be equal. That is the major segment and minor segment. Anywhere the angles are found, whatever how many angles are found, all those angles will be of equal in measure. Then theorem 10. If a line segment joining 2 points, so when we take a circle, if a line segment joining 2 points, suppose A and B, this is a line segment joining 2 points, subtends equal angles at the 2 other points, subtends equal angle at 2 other points. So this is another point and this one is other point D. Okay, 2 other points lying on the same side of the line, So this is the line segment. So 2 angles we are getting, 2 points. At 2 points angles are subtended. Okay, on the same side of the line. Not on the opposite side. Those 2 angles, those 2 points should be on the same side of the line. Containing the line segment, the 4 points lie on the circle. So all these 4 points will lie on the circle. So this theorem is very, very important. They will say that as they are concyclic. All those 4 points, if it is on the circumference of the circle, that is called concyclic. Okay, if a line segment joining 2 points, this is AB is a line segment that joining 2 points subtends equal angles. So this just now we saw the theorem, angles of the same segment are equal. So subtends equal angles, that is this angle and this angle will be equal. Angle ACB and angle ADB will be equal. Subtends equal angles at 2 other points. 2 other points is C and D. 2 other points lying on the same side of the line containing the line segment. Lying on the same side of the line containing the line segment. The 4 points lie on the circle. So all these 4 points A, B, C, D, all these 4 points lie on the circle. So we will say that as concyclic. Okay. Then next theorem is the sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Cyclic quadrilateral means all 4 vertices of the quadrilateral, if it lie on the circumference of the circle, we'll say that as cyclic quadrilateral. The sum of either pair of opposite angles. So if we join this, we'll say this as a cyclic quadrilateral. The opposite angles, sum of either pair of opposite angles of a cyclic quadrilateral is 180 degree. Angle A plus angle D is equal to 180 degree. Same way, angle B plus angle C is also equal to 180 degree. Then, if the sum of a pair of opposite angles of a quadrilateral is 180 degree, that is converse of this previous theorem, theorem 11. Converse of theorem 11 is 12. If the sum of the pair of opposite angles of a quadrilateral, if angle A plus angle D and angle B plus angle C is 180 degree, then the quadrilateral is cyclic. One more thing is, angle in a semicircle is a right angle. So if we take a circle, if a diameter is there, if angle is formed here, if angle is subtended here, this angle will be 90 degree. Semicircle is a right angle. This angle will be 90 degree. So this is the diameter and the semicircle. This one is called the semicircle. So this angle is 90 degree, right angle. Angle in a semicircle. So this forms a semicircle, that is the diameter divides the circle into 2 equal parts. So we'll say this as a semicircle. So angle in a semicircle is right angle. So we'll say this as right angle. So all these theorems are very, very important to do the sums. At the exercise 10.4 and 10.5 we are going to do in this. The previous exercise are very simple, that fill in the blanks only based on these theorems only, so that you can do by yourself. So exercise 10.4 and 10.5 are based on these 12 theorems. So I have explained this. In the next class I will be doing that exercise sums. So whatever doubts you have, you message me in the comment box. Thank you.